Hi again, this is Sammy. Today I'm going to do a little bit of geometry. We haven't done geometry for a long time, and they don't teach it much anymore. But anyways, for any students who have been doing geometry, I'm going to do questions that involve the chord perpendicular bisector theorem. And what this theorem says, it says, if you have a line going from the center and hitting a chord, we call this a chord here from here to here. That's a chord. If a line goes from the center, hits the chord at 90 degrees, what it does, it divides it into two equal segments. So let's say if this was 10, or let's say this was 8, this would have been 4, and this would have been 4, that kind of thing. So this is what the perpendicular bisector theorem for a chord is. A chord is any line that has 2 points on the circle, and anywhere except for the diameter, which goes through the center, we call that diameter. But anything that touches the circle at one point and then goes and hits the circle at another point, we call it a chord. Now, to find this here, so we have 3 questions that are we going to solve. And to solve them, for the first one here, they need me to find x. And I have this triangle right here. And I know since this is the perpendicular bisector, then this part and this part are equal. And because I have this triangle here is a 90 degrees, so this part right here, I could find it. So if I call this part, let's say y, then I could just say y equals the square root of 13 squared minus 5 squared. This is Pythagoras, a squared plus b squared equals c squared. But you know what? If I'm finding a side that's not the hypotenuse, all I do, just if I want to find, and I called it y, I just say y is the square root of the hypotenuse squared minus the given side squared. And this would be 169 minus 25, which is square root of 144, which equals 12. So y is 12, and x will be 12 times 2, which gives me 24, since this here and this are equal, according to the chord perpendicular bisector theorem. All right, so how about this second one here? This second one, they want me to find x right here. Now, I know the diameter is 14. I know this is 10. So you know what I'm gonna do, and when we write O here, it just indicates is the center of the circle. Okay, so what I'm gonna do here, I'm gonna draw a line from the center all the way where it touches the end of this chord right here. Now, I know this line here is 7 units long. Why? Because this is the diameter, and from the center all the way to the circumference of the circle, it's always the radius, and the radius is half of the diameter. So there we go. This is 7. Now, if I want to find x, also I know this and this will be equal, since this is the perpendicular bisector of a chord at 90 degrees. Then it divides this chord into 2 equal segments, so this would be 5. And now if I want to find x, I go the hypotenuse squared, square root of the hypotenuse squared minus the given side squared, and that will give me, I'm just gonna throw that in my calculator, minus 24 minus 49 minus 25 is 24. So either you leave it, you just write it an exact value. So this will give me 24, which equals 2 root 6, because 24 is 4 times 6. The square root of 4 is 2, so just wrote it as a mixed radical. Okay, now how about this third one that I'm covering with my video? So there we go. Now this is O again, and they want me to find x right here. So what they want me to find, the radius. X here is the radius, because from the center O all the way to the circumference of the circle. So I'm gonna draw another radius, which is right here, This is also radius. This would be x as well, wouldn't it? Since from here to here is the radius, also from the center to here is the radius. Now this becomes easy to solve. And x would be here. We're finding the hypotenuse, so it's the square root of 4 squared plus 5 squared, which gives me 16 plus 25, which is the square root of 41. And I'm just going to keep it in the exact value as a square root of 41. And that's geometry. You know, I haven't done it for a while. Few years back, as a matter of fact, you know, I think it was in grade 11 and it had been taken out from the curriculum maybe good 7-8 years ago. So I think I'm still sharp with geometry. I really enjoyed it. It's geometry, just, you know, you look at things and you try to derive things from the picture, you know, and it's, I wish they never took it away. Some of the geometry in grade 12 was really tough and challenging, but it was a lot of fun to do. Anyways, this is it. So so thanks for watching again. Hit that like button. Please subscribe to my channel. Also share with others so they could benefit. Till next time, take care. Bye-bye.